Within just a few decades, facial recognition has gone from being some staple of highly advanced security systems in movies to existing all around us and even in the palms of our hands. The technology has been implemented in several ways in our society. Some phones use facial recognition to grant access, and some governments, like China and the US, are using facial recognition on databases like driver's licenses for a variety of reasons. Then, we've got fun things like Snapchat filters that utilize facial detection. Now, there's a big difference between facial detection and facial recognition. With facial detection, the computer is saying, yep, that's a face. And with facial recognition, the computer is saying, yep, that's your face. This ability to confirm identity is something our brains pick up on pretty quickly when we're young, but it's actually a pretty complex problem for computers. So, let's take a look at facial recognition and the science of how it works. When you think of a human face, you probably think of a pretty basic set of features. A face has eyes, a nose, and a mouth. But obviously, there's more to a face than just these features. In fact, to get a good idea of how complex this problem can get, you can draw a bunch of different simple faces. You'll notice that they differ in a lot of factors, like the width of the nose, the distance between the eyes, the shape and the size of the mouth, and so on. Some facial recognition technologies look at up to 80 factors on the face to help identify unique features and ultimately, identities. These features get to be pretty detailed, observing things like the depth of eye sockets, the height of cheekbones, and the shape of the jawline. Of course, with so many detailed factors to be measured, some complications can arise. For instance, consider the problem of aging faces. After all, as we get older, we look different. In order to work around this, computers have learned what features tend to go relatively unchanged no matter how old we get, and they look closely at these features. But even if we didn't age, there would still be everyday complications. What happens if the computer tries to analyze your face, but you're not looking at its sensor or camera at precisely the same angle every time? This is something humans encounter on a daily basis, but never really have a problem with. For computers, though, this can present a seriously complicated obstacle in detecting and recognizing faces. So, engineers have found a few different techniques to work around this. A lot of phones that utilize facial recognition will prompt you to move your face around when you set up the facial identification system in order to know what you look like from different angles. Other systems utilize 2D to 3D technologies that map 2D images of your face onto a 3D model to calculate what you would look like from different angles. Computers measure these factors down to scales smaller than a millimeter in order to generate a face print, which, as the name implies, is basically a fingerprint, but for your face. And these face prints have become incredibly accurate. They're able to correctly identify people with a near 100% accuracy, and are even able to detect the minor differences in identical twins. As the technology has improved and become more widespread, the possibilities for its uses have grown as well. Right now, we use facial recognition every day for things like phone security, but the technology is seeing more serious uses from important organizations like banks and even governments. In Japan, some banks are looking at implementing facial recognition technologies into their ATMs as a security measure for verifying transactions. In the United States, important government agencies like ICE and the FBI are using facial recognition to create databases from existing documents like driver's licenses. Whatever the use, we know that this technology is becoming more and more present in our daily lives, and it doesn't look like that'll be stopping anytime soon. So, as is the case with all things, it's important that we stay educated and informed about these technologies. After all, they're learning as much as they can about us.